Hi guys, you guys are doing a great job in here. I know some of you feel rushed. Just remember, we've had a huge chunk of time taken away from us with all the advisory days we've had all last week and then 2 this week. I promise it won't always be like this. Let me just sum up the notes really quick if you need a filler, and then you need to add to your notes. We talked about observational studies versus experiments. The big thing with observational studies, we observe, we don't disturb. With experiments, remember, the caffeine example. We're imposing a treatment, okay? We're imposing a treatment. Now, the caffeine example that you glued in your notes was bad. Why? Because there was nothing to compare. So we went in and talked about how we could do that, and we did that we did that part on the board, okay? If you were gone, make sure you get that. We talked about breaking it up into 2 groups. Group 1 has a drink, or they all take their pulse before. Group 1 has a drink that's a placebo, and we control things about it. Group 2 has a drink that actually has caffeine in it. Then we wait 10 minutes, then we measure, and we see if there's a difference. We talked about lurking variables and confounding. I gave you the AP exam tip. And then we got into experimental design. What exactly is an explanatory variable? Remember, it's considered the cause, but I put it in quotes because we never want to use the word cause in statistics. An explanatory variable is also known as a factor, and you always want to identify how many levels there are. So for example, if I gave you an experiment and put you into 3 groups, you guys get 4 hours of sleep, you guys get 6, you guys get 8. There's 3 levels there, 4, 6, and 8. The response variable is the effect. It's what you're measuring. So if I was doing sleep and looking at the effect of grades, the grades there is your response variable. A treatment is a condition applied to the individuals in the experiment, determines how many groups you need in an experiment. If there's one factor, the treatments are the levels of that factor. Okay, so for example, in this experiment here, we would need 3 different groups. There's only one factor I'm talking about, sleep and its impact on grades. We'd need 3 groups because of those 3 levels. 2 or more factors though, the treatment is a combination of the levels for each factor. Combination, if you remember from any of your math class, you're going to be doing some multiplication. Oh, that didn't look very good. Let me try again. I need to get my pen back. You're going to multiply. That looks better. So I'm just going to finish those 2 examples with you. If you could glue those in and do it with me and then answer the questions in the Schoology quiz, that would be fantastic. Before we do that, time out. Experimental units are the smallest collection of individuals to which the treatment are applied. If they are humans, then we call them the subjects. For going back to my sleep example, the experimental units on here when I was talking about it in class would be the students. I'm testing the students, right? I'm applying the treatment to my students because I was saying you guys get 4 hours, you guys get 6, you guys get 8. Now let's go through example 12, a lousy situation. A study published in New England Journal of Medicine compared 2 medicines to treat head lice, an oral medication called ivermectin, a topical lotion containing, I'm going to botch this, malathion. Researchers studied 812 people in 376 households in 7 areas around the world. Of the 185 randomly assigned ivermectin, 171 were free from head lice. After 2 weeks, compared to only 151 of the 191 households randomly assigned to the malathion. Okay. Identify the experimental units, the explanatory and response variable, and the treatments in this experiment. The experimental units. Researchers studied 812 people in 376 households. Now, what you have to decide is, of the 185 randomly assigned to ivermectin, what is that 185? Is that 185 part of the 812? Or is it part of the 376 households? And it's actually part of the households. So that's your I can smell, I promise. Right? That's your experimental unit there. What is happening? The treatment is going to the households. Yes, or you could say the people in the households. That would be okay as well. Okay. Next, the explanatory variable. EV. For the explanatory variable, what's going on? Okay. Compared two medicines to treat head lice, oral and topical, right? So the explanatory variable is the different medications. That's all they're looking at. And how many levels are there? There's 2. That means there's going to be 2 treatments, right? So, how do I get a new page here? I'm going to have to go to the end to fix it. The 2 treatments then, because there's 2 levels and only 1 explanatory variable. Let me be clear again. When there's only 1 factor, the number of levels is how many treatments you're going to get. Okay, so the 2 treatments would be either the topical or the oral medication. And finally, the response variable would be what? We're trying to see how many households were free from head lice. And now what we'll do then is we'll look at those proportions or those percentages and we'll compare them. And then statisticians will make a decision and they'll say which one is more effective. Let me just sum it up again for your understanding and mine. The experimental units is who's getting the medication. The household. Certain households are getting the medication. Everyone in this household will get the topical medication. Everyone in the other household will get the oral medication. The explanatory variable is the different meds. Okay, what are we looking to see is going to influence having head lice or not? There's 2 levels because there's 2 different meds that are being taken. The treatments then would be whatever those levels are, the topical and the oral. Okay, and then just remember, when there's 1 factor only, and the number of levels is how many treatments there will be. This will change for number 13. The response variable, though, of example 12 was the number of households free from head lice. And what I said is then statisticians will look at the percentages for the different med groups and decide which one is more effective. Now let's finish up with example 13, growing tomatoes. Does adding fertilizer affect the productivity of tomato plants? How about the amount of water given to the plants? To answer these questions, a gardener plants 24 similar tomato plants in identical pots in his greenhouse. He will add fertilizer to the soil in half of the pots. Also, he will water 8 of the plants with 0.5 gallons of water per day, 8 of the plants with 1 gallon of water per day, and the remaining 8 plants with 1.5 gallons of water per day. At the end of the 3 months, he will record the total weight of tomatoes produced on each plant. Identify the explanatory and response variable, the experimental units, and list all the treatments. Let's start with experimental units, EU. The experimental units is what's happening. So we're looking at tomato plants. Right, and I'm running out of room there. I'm sorry, okay? Next, we want to talk about the explanatory variable, also known as the factors. Okay, well, it looks like he's going to be giving water to them. So 24 similar tomato plants in identical pots in his greenhouse. But he's also going to be giving fertilizer. So the fertilizer is one explanatory variable or one factor. And then the water is the other factor. Okay, so for the fertilizer, it says he'll add fertilizer to half the pots. So that means there's two. Let me change the color on us here. Levels. Oh, can you see? Right? Rewrite it down here. Okay. The water now. It looks like he's going to give 0.5 gallons of water. He's going to give 1.5 gallons of water. And then, is that it? He will water 8 of the plants with 0.5 gallons, 8 of the plants with 1, and 8 of the plants with 1.5 gallons. So there's 3 levels for the factor of water. Okay, now let's get to the treatments. Okay, the treatments then, for this one, and be clear now, I'm going to change my, can you see okay? Yep. Okay, so the treatments, when you have more than one factor, you have to look at your factors individually. So the first factor was fertilizer. And you look at the levels, and then you multiply it times the levels for the other factor, okay? The other one was water. And you look at the levels. So the fertilizer, there was 2 levels, times the water levels, there was 3 levels, gives us a total of 6 treatments, okay? To identify those treatments then, we would say you could make almost a tree. Half the pots, right, will get fertilizer. Half the pots, no fertilizer. Okay, then with the fertilizer then, some will get 0.5 gallons, some will get 1 gallon, and some will get 1.5 gallons. With the no fertilizer, the same, 0.5 gallons, 1 gallon, and 1.5 gallons. How many treatments do we have then? You can look and you can say fertilizer plus 0.5 gallons, fertilizer plus 1 gallon, fertilizer plus 1.5 gallons. No fertilizer plus 0.5 gallons, no fertilizer plus 1 gallon, no fertilizer plus 1.5 gallons. There's 6 different treatments, which means when we're doing this experiment, we need 6 different groups we're looking at, okay? This group part will make more sense tomorrow when I talk about more experimental design and how it will all look, okay? The big thing is that you can identify this right here, all the different treatments, and you can label it specifically. Lastly, we have the treatments, we have the experimental units, the response variable. I'm just going to say that in words so I can wrap this up. At the end of the 3 months, he will record the total weight of tomatoes produced on each plant. Okay, so right here, That's my response variable. And I would write that down in my notes if I were you. Wow, I hit 15 minutes. I'm sorry, guys. You're doing a great job. I will make a clear, updated list on what is due tomorrow because some of you were confused and asking me questions. Have a great night.